Only girl, one of that one day.
Response.
What is your brain? Oh, yeah.
She's here now.
Oh no, they're all saying different.
The attorney I hired was attacked.
We have money. We still want to die for money. That's what we are looking for money. I want to fight
I tried my best possible.
Good morning, Mai.
Please, let's continue the class. What happens? Oh. Okay, valence electron simply means the electron at the outermost shell of an atom. Now, if you talk about carbon, carbon has 6. The atomic number of carbon is 6. You know that on the first energy level 1, it has 2 electrons. So energy level 2, it has 4 electrons. That's 2s2 and 2p2. So that's why carbon have 4 valence electrons. So the valency simply means the combining power, okay, which means that electron at the outermost shell of an atom. This valence electron is responsible for ability of electron to accept or donate electron. So it also influences its the shape of this compound is influenced by the valence electron. So this valence electron leads us to valence forces. Valence forces are attractive forces that hold these compounds together, hold particle atoms, molecules together. If you talk about valence forces, we can talk about ionic bond is a valence force. Covalent bond is a valence force. I'm going to talk about some other valence forces today, which are something like intermolecular or intramolecular valence forces. Talk about hydrogen bonding. Hydrogen bonding is a valence force. Okay. Van der Waals force is also a valence force. These are valence forces. These forces are forces that hold constituents, atoms, molecules, or ions together in a molecule. So now when you talk about a compound, something are responsible for this compound coming together, like hydrogen and oxygen coming together to form water. There's a force that binds them together. This force are called valence forces. So remember from the previous slide, we talk about ionic bonding, we talk about covalent bonding, and we talk about this bonding as strong, right? We'll talk about that metallic bond are stronger than ionic bond, while ionic bond are stronger than covalent bond. Okay, so intermolecular and intramolecular forces, example of them is hydrogen bonding. Hydrogen bonding is a valence force. The hydrogen bonding is weaker than covalent bonding. okay, but stronger than van der Waals forces. Please, whenever I'm talking, I expect you that you have your notes, because not every slide are PowerPoint. Slides are not enough. That's why it's important to be in class. If there is no need of, if what is on the slide is all that you need, somebody would have sent slides to you and say, go and read off. So the essence of class is for the slides to be expatiated on or explained for better understanding. So whenever you're in a class like this, make sure you're making a note. Okay. All right. So having said that, we are talking about the hydrogen bonding can be inter or intra. When you're talking about inter means between two people. Inter has spots, meaning between one school and another. So intermolecular is hydrogen bonding is hydrogen bonding that has to do with two. That has to do with two compounds or two molecules forming a bonding. We call that kind of bonding hydrogen bonding. Okay. Now, when you talk about intra, it means that within that molecule, a molecule within itself can form hydrogen bonding. So that's types of hydrogen bonding. We have intermolecular and intramolecular. Remember, we are writing tests today. I've said so many things already. And today's test, you're not going to see it on the shared on the screen. Today's test, I'm going to ask questions and you respond to me. And you respond by writing. So it's not about this person will tell you it is A, another person will tell him it is B. Okay, so let's continue. Now, another thing we need to talk about whenever you're talking about valence forces is dipole-dipole interaction. What does this dipole-dipole interaction mean? It means that these forces that occur when there is partial positive and partial negative charges in a molecule. So meaning when partially positive charge of a molecule interact with partially negative charge of the neighboring molecule, we say that is dipole-dipole interaction. So if partial part of positive charge of positive ion in hydrogen connects with another negative part of oxygen of a neighboring molecule, we say that is dipole-dipole interaction between that compound that has hydrogen and the compound that has oxygen. Okay. Now, this dipole-dipole interaction is a prerequisite when you're talking about polar covalent bonding. Example, you can see hydrogen and chlorine. So, for there to be a polarity, there must be positive charge connecting to negative charge. So, the strongest type of dipole-dipole interaction. Dipole-dipole interaction is the strongest intermolecular force of attraction. So that the strongest intermolecular force of attraction is called dash. Dipole-dipole interaction, ionic bonding, covalent bonding, metallic bonding. I know you know the answer. Okay. The strongest intermolecular forces. Remember, intermolecular forces are forces between two molecules, one molecule and another. That's why inter, between one molecule and another. Now let's talk details about hydrogen bonding. Hydrogen bonding, we just talk about intermolecular dipole-dipole interaction. So hydrogen bonding are formed due to that dipole-dipole interaction between hydrogen atom bonded to highly electronegative atom. Now let me explain. For there to be hydrogen bonding, two things must occur. Number one, there must be electropositive atom and there must be highly electronegative atom. So when there is no presence of highly it means that it's not just that they're almost the same. There must be difference in electronegativity between the atoms for there to be hydrogen bonding. Example is hydrogen and chlorine. You know there is a wide gap in terms of electronegativity between hydrogen atom and chlorine atom. So in that case, they can form hydrogen bonding. So one of the conditions is that they must contain highly electronegative atom. And this must lead to hydrogen. That's why they call it hydrogen bonding. Hydrogen bonding to highly electronegative atom. Now, if you have more than, like we talk about, example is halogen. Halogen, we have fluorine, chlorine, bromine, iodine, and others. Now, the higher the electronegativity, the more the polarization of the molecule. It means that the one that have high electronegativity is going to will have high hydrogen bonding, and is going to have high boiling point. We're going to talk about why boiling point in hydrogen bonding. So what in terms of halogen, remember electronegativity decreases as you move down, meaning that fluorine is highly electronegative. So if you have a compound like hydrogen chloride, hydrogen chloride, hydrogen bromide, and hydrogen iodide, they say which of the following will have higher hydrogen bonding? I know you know the answer now. They will tell you arrange the following in order of decreasing hydrogen bonding: hydrogen fluoride, hydrogen chloride, hydrogen bromide, and hydrogen iodide. So you should be able to arrange them in order of. Please mute yourself, or except I will take you out of this class. So you should be able to arrange them in order of their increasing or decreasing hydrogen bonding. Now, the size of this electronegative atom should also be small, because the smaller the size, the more the electrostatic force of attraction. Why? Because when these atoms are small, the interaction between the proton and the electron will be more. The wider, the less, because of shielding effects. So that's why the smaller the size, the greater that force of attraction, the stronger the hydrogen bonding. So the two conditions for hydrogen bonding is the small size and high electronegative atoms. Remember, it is hydrogen that is bonding to highly electronegative atom. That is hydrogen bonding. Taking? Yes. I've answered for you.
Slide. Alright.
Sorry?
Can you wait a little bit on the slide? Yes, ma'am.
You're not right. I'm going to share the slide with you. Okay. Now, hydrogen bonding. Compounds that have hydrogen bonding, one of the characters or benefit that is good, they're going to have abnormally high melting and boiling points. Hydrogen bonding causes a compound to have high boiling and melting points. Now, an example is that I can share some compounds like the halogen. I'll say which of the following will have highest boiling or highest melting points. Now, the answer is which one has the highest hydrogen bonding. So when you know the compound that have the highest hydrogen bond, you should know the one that have the highest melting point or boiling point. So example of the halogens. If I share the halogens now, like I said which of the following halogen or which of the following acids, just HCl, HBr, and HI, will have the highest boiling point. I think you should be able to answer that question without wasting a second. Because you should which of them?
HCl.
Why is it HCl?
Why is HF?
It's HF
It's
now.
HF.
HF.
We are still in the class, or somebody is mixing it up. Please, it's HF because that's what have the highest hydrogen bonding. Thank you. So the one is it. Hello?
Sure.
Who is asking questions?
I said I don't understand how you got the highest bonding, man.
Which one has the highest hydrogen bonding? What are the conditions for hydrogen bonding?
It must be highly electronegative, man.
Okay, now between hydrogen and fluorine, which one is highly electronegative?
Ma?
Between hydrogen and fluorine, which one is highly electronegative?
Fluorine, ma'am.
Between fluorine and chlorine, which one is highly electronegative?
Oh, fluorine, ma'am.
Okay, fine. So that
Thank you,
answers
ma'am.
that question. Thank you. Now, the one is that because now, remember, fluorine, that's why normally if you look at chemicals, before you see hydrogen fluoride to be used in the lab, because it's highly corrosive, it's very, very reactive. Now, there's a need for extra energy to break this hydrogen bond. So that is why whenever there is need for extra energy, it causes high melting or high boiling point. So why are they exhibiting abnormally high melting and boiling points? Due to extra energy needed to break the bonds. Just like when we are talking about metallic bonding, the same thing applies. So whenever a question has to do with high melting or boiling point, it means that there's a force that needs to be overcome and extra energy is needed. So that's why the boiling or melting point will be high. So it's cut across everything that has to do with high melting or boiling point. That must be something you need to overcome, some more energy. Okay. So example of hydrogen bonding is high boiling point of hydrogen fluoride among the halogens. This just what we just answered. This is existence of hydrogen bonding. Why is it that ethanol has higher boiling point than ethyl ether? Is it because of hydrogen bonding? Ethanol has boiling point of 78. Now, ethyl ether on its own don't need to boil because on its own it evaporates. It's very volatile. If you talk about water and ethanol, their boiling point is virtually similar, but water has higher. 100, ethanol is 78. So the higher the hydrogen bonding, the higher the boiling point. Okay. Now let's talk about the types of hydrogen bonding. So we have hello?
Yes, ma'am.
Any question?
Yes, ma'am. Ma, please, I didn't get the diethyl. You said ethanol has boiling point of 78%. Then you said
Yes,
diethyl
ethyl ether.
Okay.
I said ethyl ether has a very lower boiling point because it's a very volatile compound.
Okay, ma'am.
Yes, volatile compound. Even without it can evaporate. You know, if you look at the bonding of diethyl ether, there is no electronegative atom, right? Do you know the formula of diethyl ether?
No, ma.
Diethyl ether is ethyl, 2 ethyl, and there is oxygen in the middle. What's the formula for ethyl?
C2H5.
C2H5. So C2H5, oxygen in the middle, and that's C2H5.
That is
So that's
C2H5.
Oh, yes. So that's it. So if you look at it and look at ethanol, you realize that the hydrogen bond in ethanol is very high. So that is why ethanol has a higher boiling point, and diethyl ether is very volatile because the bonds that surround this are non-polar bonding. Okay, sorry for that interruption. So I said there are 2 types of hydrogen bonding. We have intermolecular, we have intramolecular. Now, intermolecular is within, like I've explained it before. Why intermolecular is between one molecule or another. Like you talk about water and ethanol, they can have a hydrogen bond intermolecular because there is a connection. So it might be hydrogen from water can link with oxygen from alcohol. They form hydrogen bonding. Okay. Water and ammonia can also form because hydrogen can link with the nitrogen in ammonia. So that is hydrogen bonding that is between 2 compounds. It can also be water and water, it can be the same, or ethanol and ethanol. 2 molecules of water can form, 3 molecules of water can form. The same thing with other. So it can be within with the same compound or with another one. But minimum of 2 compounds are involved in the bonding. Why intra is when you do the one that happens within the compound itself. Like I said, the hydrogen bonding is also weaker than covalent bonding, but stronger than van der Waals force of interaction. So now, all these are called valence forces. So we have ionic bond, we have covalent bond, we have hydrogen bond, we have van der Waals interaction. These are all valence forces. So it is shown on the slide. Their strengths. The weakest one is van der Waals, while the strongest is ionic bonding. So it should be the question can say the following, I'm talking about question for today, but if it's in your normal CBT, they can list the valence forces and say which of them is the strongest or weakest. Or they say arrange the following valence forces in order of their strengths. Okay, so however the question comes, make sure you understand it.
Sorry. Ma, I want to confirm, is metallic bond stronger than ionic bond?
Exactly.
Yes. I've said it several times.
Because metallic is aging.
I've told you several times, okay?
Ma, did you say yes
If you look at metallic bond, there are so many ions and the sea of electrons, so it should be stronger.
Okay.
That yeah. But in ionic bond, you're talking about one ion and one cation and one anion. With this one, there's so many, so that's why it's strongest of all. Any other question before we proceed?
But ma, what about
Yes, ma, please. Ma,
Sorry,
please. Is metallic bond part of the valence forces? Hello, ma. Did you get my question? Is
Okay.
metallic bond part of the valence forces?
No. The valence forces we are talking about ionic bond, covalent bond, hydrogen bond, and van der Waals interactions.
Ma.
Excuse me, ma. Is hydrogen bonding stronger than dipole-dipole interactions, or is it a form of dipole-dipole
Now,
interaction?
hydrogen bonding is a type of interaction that we see. Dipole-dipole is what we see in hydrogen bonding. So it's in hydrogen bonding.
Ma, just to get something clear, you said van der Waals has the strongest hydrogen bond. Ma?
Go back to the slide. I said that van der Waals forces are the weakest.
Oh.
Are the weakest kind of bonding.
Okay, ma.
Hydrogen bonding is weaker than covalent bonding, but stronger than van der Waals forces. It means that in all the valence forces, van der Waals are the weakest.
Okay, ma.
Please, nobody should send any chat to me. I'm not reading chat. If you have questions, just ask question. I'm not reading.
Good morning, ma. But you said dipole-dipole interaction is the strongest intermolecular force.
That is intermolecular force. We are talking about valence forces. If you're talking about dipole-dipole interaction is a strong intermolecular forces. Remember, we are having dipole-dipole interaction if you're talking about ionic bond. What is dipole-dipole interaction? When you understand that, dipole-dipole interaction is what you see when positive X connecting to a electronegative center. So if you look at the issue of metallic bonding, but virtually in all the bonding that has to do with positive and negative, there is always dipole-dipole interaction, because it links the positive center connecting to electronegative atom. So even in hydrogen bonding is there. So let's go
Sorry, ma.
to
Excuse me, ma.
Nonsense confusing.
ask your question.
Ma, in my textbook, it says that dipole-dipole interaction is a form of van der Waals forces.
Which of the textbook?
Dipole-dipole. New school. It
In
says that
today,
dipole-dipole London dispersion is the two forms of van der Waals forces.
well, what I'm telling you today is that hydrogen bonding is now what is dipole-dipole interaction?
You said that dipole-dipole interaction is when a partially electropositive atom interacts with a partially electronegative one.
Okay. So what is your problem here now? I said
No, my
dipole-dipole
problem.
interaction are the strongest intermolecular force of attraction.
Yes, ma'am.
Because it involves positive center and negative center. That is forming bonding. And remember, in ionic bond, we also have it. It's like it is virtually cut across all the bonding that have to do with electronegative center and positive center. Now
Ma,
we are
does
going
that
to
imply Ma,
ask your question.
does that implies that in ionic bonding there is a dipole-dipole
Virtually
interaction?
in every kind of bonding. See, when you want to understand chemistry, I don't want us to cram chemistry. I want you to understand the basics. Now, what is dipole-dipole interaction? If you understand what is dipole-dipole interaction, you understand what it means. Now, interaction. Remember, if you come to sodium chloride and HCl, there are some compounds that have higher interaction more than others. Some dipole-dipole interaction are strong in some compounds and weak in other compounds, depending on the atoms forming the bonding. If you talk about dipole-dipole interaction in HF and the one in HI, which one is stronger?
HF.
Yes. So I want you to understand it that way. So let's go to what we are here for. Please, whatever we're doing, let's do within the limit of this course. Some of these things, when you get your 200 level, you will understand it better. But this is the basis you need to understand now that they are going to build on. Now, let's talk about, this is the last model we want to talk about. We are talking about valence shell electron pair repulsion theory. This is a theory that determines the shape. Remember, we talk about hybridization, which was valence bond. This one is now valence shell electron pair. Now, this model is simply telling us that when there is presence of lone pair of electron in a compound, in a central atom, there's a tendency that the expected shape of the compound can change because of repulsion between the lone pair of electron and electron pair. A typical example is, now remember in nitrogen, well, I'm going to share example when we'll get to the next slide, but I want to explain. In ammonia, we have nitrogen, and nitrogen has a lone pair of electron. So and the bond pair is something like hydrogen coming to form a bond. Because of this lone pair, there will be repulsion between hydrogen and the lone pair. So the expected shape of ammonia will not come again. The bond is going to adjust. So the bond angle is going to reduce and the shape is going to change. So that is, the reason is that whenever there is presence of lone pair in a central atom, remember, if you're looking at shape of any compound, you're looking at the central atom. The central atom is going to determine the valence electron in the central atom is a determining factor. So in this theory, when there is lone pair of electron, the expected shape is going to change. But when there is no lone pair of electron, the shape remains. So let's use this as an example. If you look at this compound, we have beryllium hydride. By atomic number of beryllium, we have how many atoms? What's the atomic number of beryllium? What's the atomic number of beryllium?
4.
Now, how many electrons do we have what's the valence electron?
2.
Now, because there is no lone pair of electrons, this valence electron, hydrogen will come and bond in one. Another one, remember, is now hydrogen is going to come and form in one. Another hydrogen will form in another one, occupying the valence electron, meaning that this beryllium does not have any form of repulsion. So the structure expected is structure we're going to get linear.
Okay.
Now, if you go to boron has 3 valence electrons. So chlorine are going to come and occupy those valence electrons, forming a trigonal shape as expected.
What did you say?
Without any problem. Then when we come to ammonia, because of presence of lone pair of electron in ammonia, this lone pair is going to cause the hydrogen, the bond pair, which is hydrogen. There will be a repulsion between hydrogen and this lone pair, affecting the expected shape of ammonia. So giving ammonia trigonal shape. So now ammonia is going to have trigonal pyramid shape as drawn instead of tetrahedral. So that is why ammonia cannot be tetrahedral. And because why? This repulsion is going to cause decrease in the bond angle. So causing the shape to change entirely. So meaning that if I'm looking for the shape of a compound, if there is presence of lone pair of electron, there must be repulsion that is going to affect the shape, the expected shape, which is going to bring about decrease in the expected bond angle. So that is what this valence shell electron pair repulsion is talking about. So whenever you talk about the following can be used to predict the shape of a compound, except at times this valence shell electron pair can be twisted. Instead of valence shell, they say valence electron shell repulsion theory. So in that case, whenever you're reading, read in between the lines and understand it. So the one that we talked about is valence bond and valence shell electron repulsion. Different between the two is this one has lone pair of electron that bring about the repulsion. In hybridization, we're not talking about lone pair. Where in valence shell electron pair, we're talking about the presence of lone pair. That's what affected the expected tetrahedral shape of ammonia going to trigonal pyramidal shape. So ask your question before we go to this. I want us to revise the last test so that you'll be well informed. Then we go to today's test and end the class. Please, for the sake of FSC 112, whatever your thoughts under this, we are talking about the basis. But when you get to your higher class, some of this basis will be expatiated and you'll understand it better. So that we don't intimidate our brethren that are weaker, that are coming from biological sciences or that don't have science background. And whatever you're being taught is what you're going to be, that's the question that will come out. So don't go and start asking your friends questions that is beyond this syllable. Because at times when you read too much, if you enter exam, or you can be confused. Can we go ahead for the test questions?
Question,
Or do you have
ma.
any-
Question, ma.
Please, I have a question.
Okay. According to one of the slides that you just dropped, maybe 2 slides back, I'm not sure. You said
Okay,
that
great,
ionic
great,
bonding
great.
is yes, this no. No.
This
No,
one,
the next
this
one.
one.
The next one. No. The one where you showed ionic bonding, covalent bonding. Yes,
Okay,
this one.
okay,
You said
okay.
from this slide, on this particular slide, ionic bonding is meant to be stronger than covalent bonding, but
Yes,
as
yes.
most of us might well know, this added substance in the word is diamond, right? And diamond is made up of covalent bonds, carbon
Yes,
to
made of
carbon.
covalent bond.
So is that not meant to be stronger?
I noticed the handwriting is different. The handwriting is different.
Now,
You know,
ionic
the
bonding in terms of now,
Now,
remember, if you're talking about if you're comparing covalent bond,
if you're comparing
you're talking about
covalent
sigma
bonds,
bond. You're not talking about sigma bond and pi bond. Sigma bond and pi bond. Now, covalent bonding are two types. If you're coming in a compound like alkane, we call this covalent bonding sigma bond because we can have sigma bond, we can have pi bond. I said that sigma bond is a bond that as soon as it's broken, the compound breaks. Now, in terms of strength we are talking about, remember strength we are talking about now of this ionic bond being the strongest bond. Ionic bond is talking about the force of attraction here. If you are talking about, remember you're talking about the compounds or the atom that made up this bond because of electronegative atoms. And if also you're talking about metallic bond, you're talking about the presence of positive and negative ions that make it to be very strong. So the strength depends. Now, if you're talking about a bond, you're talking about hardness. We're not talking about hardness. We're talking about strength in terms of chemical strength. So there are two different things. We're not talking about tensile strength. No. We're talking about in terms of reaction. The ions, that is what talking about. If you're talking about boiling point, ionic bonds can have higher boiling points. Just like talking about chlorine molecule. Remember the compound we're talking about. Talking about oxygen molecule and the hydrogen chloride. Which one is stronger? Answer my question. When you have hydrogen molecule and you have a hydrogen chloride, which one is stronger?
Hydrogen chloride.
That's what I'm talking about.
hydrogen chloride.
Talking about the strength, as in talking about tensile strength. We're talking about the strength, chemical strength. So in terms of reaction, in terms of reactivity.
Excuse me, ma. Excuse
Hello,
me, ma.
ma. Please, ma, can you explain the valence shell electron? I'm struggling to understand that, ma.
Valence shell electron is the electron at the atomos shell of a compound. Example, carbon as an example. Carbon has atomic number of 6. Now, if you want to use energy level 1, energy level 2, the first energy level is going to have 2 electrons. Second energy level is going to have 8 electrons. But in carbon, we have 4. So that 4 is at energy level 2. So the valence electron of carbon is 4. And that is why when carbon is forming bonding, it has 4 sites. It must use the valency of 4. So this valence electron is the combining power or the electron at the atomos shell of an atom. If you talk about oxygen, oxygen have atomic number of 6. So it means that the first energy level, oxygen have atomic number of 8. First energy level is 2. Second one is 6. Meaning that instead of giving us 6, it's easier for you to borrow 2. So that's why it has valency of -2 because it's going to borrow 2. So in valency, we put plus or minus. That's why we talk about magnesium is represented as 2+ because magnesium can give out 2 electrons. It has SS2. It can give out 2. So whenever it is plus, it means it's what somebody can give out. When it is minus, it's what somebody can borrow to complete its octet structure. Octet means 8. So the maximum electron apart from first energy level is 8. So when it cannot complete its octet, it can either borrow or it can give out when it has excess. So if in magnesium, the second energy level is complete, we get to the third energy level when it has 2. So that 2 can easily be given out. So that's why magnesium is Mg2+. Oxygen has 6. It can borrow 2. So that's why oxygen has O2-. So these are what you use in combining. So in water, we have oxygen to be 2-, hydrogen to be 1. That's why water has H2O. So that is what we use to combine in reaction. That's what we use in forming compounds, how they combine. So you cannot see magnesium in magnesium being 2+, oxygen being 2-. So we have magnesium to be MgO because the 2 annul themselves. But if one has 2 and one have minus, they will cross themselves and form a compound. So that's a combining power. of atoms is
Yes, ma.
valence.
But in terms of
Ma,
shaping the compound, that's what I'm talking about. Valence
Okay,
shell
now,
electron.
yes, in terms of shaping the compound, let's use the example of nitrogen. Now, if you talk about in that nitrogen has atomic number of what?
7.
7. So what's the value? Now, in that 7, 1s2, 2s2, and 2p3, right?
Yes, ma.
Now, you realize that 2s and 2p is the one that is going to participate in bonding. Now, if this 3p is already on its own, they are already bond pair because hydrogen is 3 in ammonia. But you have 2s, which is lone pair of electron that is not participating in bonding. So the valence electron for nitrogen is what? What's the valence of electron? Now, that's why valence electron of nitrogen, we can
It's
now in this hydrogen and nitrogen have 2s2 and 2p3. Now 2x is not participating, is labeled because it's lone pair, it's on its own, it has been paired already. But 2p is already one valence electron that can form bonding. But this one is still lone pair. That lone pair is what is represented by two dots. Hello?
Ma, please, I have a question, ma. Ma,
Let
when
me
you want to
finish
determine...
Okay.
Never
Is it
finish
okay?
explanation now.
Wait,
Let me finish this one
it's
first.
based on what she's saying. It's based on what she's saying.
Okay.
Ma, when you want to determine valence electron, is it the electronic configuration of 2,8 or 1s that you use? Which one?
Both of them. It depends on the one you're familiar with. Valence electron is one that is on the atomos shell. So anyone that you're familiar with is fine. But remember, in that level, it must be on the same energy level. That's why we're using 2s.
Okay, ma.
We're not using 1s. So in that case, when my hydrogen is bonding, my hydrogen is supposed to bond in tetrahedra. But it cannot, because of the repulsion between this electron that is not pairing, it cannot stay because it's lone pair. It's going to repel them.
No, sorry, I don't understand.
What don't you understand? Is it the repulsion? Let's go to that. Okay.
Sorry, I don't understand.
You don't understand what? Is it the valence electron or the repulsion aspect of it?
The repulsion aspect.
Repulsion occurs when there is presence of lone pair.
Okay.
It's only lone pair that can cause repulsion. The lone pair on the central atom. Central atom here is nitrogen. If there is no presence of lone pair, there will be no repulsion. But because of the lone pair, this expected structure of ammonia is not what we are seeing. Ammonia is supposed to be tetrahedral because of sp3. But because of this lone pair of electron, ammonia is no more tetrahedral. Ammonia becomes trigonal because this lone pair is going to repel the bond pair of hydrogen and going to make the shape to come down. It's going to bring them down. They cannot, just like I am the sheep. Why do you want to come and stay on the same level with me? It's going to pull them down. So the shape changes because the bond angle is going to decrease from expected bond angle of 109.5. It's going to reduce. So instead of tetrahedral, we're going to get trigonal pyramidal shape in ammonia. But look at other ones, like boron trichloride is having the trigonal as expected. So the presence of lone pair is what causes some shape to deviate from normal expected shape of bond angle or valence bond. Ask your question before we go for the test.
Jesus Christ!
Some people are just using this question to distract me.
Excuse me, man. Interaction.
So let's revise this, please. Let's revise it, please.
Let's start the quiz, right?
Now, ionic bond formation depends on arrangement of dash. What's the answer?
Ions.
Latin.
Ion, ma.
Atom.
Atoms. Lattice.
Iron.
Mine is a yons. It's a
Iron.
yons.
Lattice.
Lattice.
Iron.
Lattice.
Atom.
Iron.
It's
Lattice.
lattice.
Is lattice.
Iron.
Yes,
Iron.
please.
Lattice.
My iron.
Ions.
Atoms.
Lattice.
Hello.
Lattice.
It's okay. Let her tell us the answer.
What is by the version of the word ionic bonds? What's supposed to be the answer?
Ions.
Ions.
Iron.
Number two. What's the answer of number two?
Last time.
H2.
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 That's number two.
H2.
Number two is H2. Number three.
Chemical bond.
Chemical bond.
Chemical bond.
Number four.
H2.
Chemical bond again.
Number four.
Sorry.
Dipolar bond.
Dipolar bond. Chemical bond.
Two chemical bond.
Ionic
You
bond.
want to read that
Number
first?
4 is chemical bond, right?
Number 5.
My
Please, number 5 is not
Number 4. What's number?
Ionic
Four
bond.
is
number 4 is
dipolar. It's
not
a
dipolar.
Number 5 is
Number 5.
Mom, please, we can't get the correct answers. Choose the multiple answers.
Ionic bond.
Oh yeah, okay.
Wait,
Everybody
number
muted.
4. What's the answer for number 4?
Muted.
Number 5, ionic
It's on my
bond.
jaw.
Mute, please.
Number 1 is D. Number 2 is D. Number 3 is C. The force that holds compound together in a chemical is called chemical bond. The following are types of bond except chemical bond, because it's not a type of bond. Dipolar is a kind of bond. Dipolar bonding is the same thing with what? Dative bonding. So dipolar is a kind of bond. Now, whenever you're in exam hall, listen. There's something they call elimination method. Always employ when you're confused. Employ who is I will stop this. Whenever you're in exam hall and you're confused, use elimination method. Take away the ones that are not. Then it will give you fewer options to choose from. The type of bond that involves complete transfer is ionic bonding. Another name for dative bonding is coordinate ionic bond, dipolar bond. The answer is dipolar bond. Yes.
Number 5.
Please, I want to ask a question.
Number 5.
Please, I want to ask a question.
Number 5 is ionic bond. Complete transfer is ionic bond.
Number 5 is ionic.
Yes.
Please, I want to ask a question.
Okay.
Please, that number 1. How is
Sorry.
it?
The complete transfer of electron pair. Electron pair is coordinate bond. Is coordinate bond. Complete transfer of electron pair is coordinate bond.
But what about magnesium?
I thought they are sharing the pair.
They're sharing it now.
They are sharing.
Complete transfer.
Ionic, they are transferring. It's still 2 electrons, so it still makes a pair.
Now, let's argue it up. What is dative bonding?
Dative bonding is when there's a sharing. One element shares.
In dative bonding, there is no complete transfer. One is more electronegative than the other. It's bringing it closer.
What is dative bonding?
Okay.
A type of bonding that involves complete transfer of electron pair. Complete transfer of electron pair is ionic bonding.
Ionic
bonding.
Because they are transferring electrons.
When one of the atom
Electromolecular to ionic
contribute
bond is complete transfer of
Yes,
electrons.
contributes
bring about contribute the electron that is being shared by both.
by the two of
Yes,
them.
ma.
Yes.
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 Ma, please, I
So
want to
whenever it
ask a
is shared,
question.
electrons share being contributed by one.
Wait now,
Whenever
let's
there is
explain the
sharing,
thing finish.
so
Now,
it becomes coordinate bond. So another name for dative bonding is what? Dipolar
Dipolar
bond.
bond.
Dipolar bond.
The type of bonding that involves C of electron is what?
Metallic bond.
Metallic bond.
All covalent bondings are non-polar. True
Number
or
6
false?
is bipolar
False.
bond.
False.
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 All some ionic bonds are polar. True or false?
True.
False.
False.
It's all.
All ionic bonds that are polar.
All ionic bonds are polar.
Oh, sorry, ma.
True, no, it's all ionic bonds are polar.
Exactly.
Please, you're not getting the right answers. You just
All ionic bonds are polar, not some. Because of that some, the answer is false. Okay, so
Ma,
whenever you
number
want to
6.
understand it,
What was the answer for number 6, ma?
You guys should stop interrupting
number
and now
6
let her
is B,
finish first.
dipolar bond.
Rest.
Please, for number 5, what did we conclude on?
Ionic bond.
Ionic bond.
Sorry, ma.
Metals are conductors of electricity
Sorry, ma. What did
because
they
of
say is the
what?
answer for number 1? What's the answer for number 1?
Presence of the
Please, can you repeat, abeg?
ions.
Number 1.
Number 1 is ions now.
Ma, how
All
is it
conve-
ions?
Ma,
metal
I have a question for number 1.
Light electrons.
Ma, I have a question for that number.
What is number 1
Are
is
we
what?
going forward or backward?
I don't understand.
Ionic bonds.
What is so
So,
confusing about it?
please, I suggest you tell us the answers for all the questions, and later questions can come in.
Oh yeah, better. So please,
Ma, can I ask a question? For number
nobody
1?
should interrupt.
Oh,
If
yeah,
you interrupt,
Go
I'll stop.
ask.
If you interrupt, I'll stop. If you mute yourself, I'll stop. Metals are good conductors of electricity because of presence of what? The localized
Localized
electrons.
electrons.
The high energy needed to overcome
Ma, I have
electrostatic
a
force of
question.
attraction
Shut
is responsible
up.
for high
Alpha
boiling and
guy,
melting
chill.
points. That's number 11D. A metal is made up of atoms. That's 12C. The form of matter that can be compressed up, down, and sides are gases. The process of purifying sands contaminated with iodine is sublimation. The following are properties of gases except high density because they have low density. The mixing of 2 or more atomic orbitals is called hybridization. Hybridization of carbon is sp3. For hybridization to occur, electron must be in excited state. The bond angle in alkyne, and alkene are 109, alkyne 180, and 120. So the option is C. The hybridization of 25 for S character and 75 P character is sp3. The shape of ethane, 18 and ethyne respectively are tetrahedral, trigonal, and planar. The electron in p orbital is what?
I thought
electrons.
trigonal planar is together, like they are one word.
I thought
Yes,
trigonal
yes.
planar is
What's
together.
really
What's the answer for number
Planar is linear. Planar also means
now.
linear.
It does not mean
Trigonal
Also means
linear.
linear.
It does not mean linear. Please go and check well.
You
Yes, it's
cannot have
linear.
Jenny, rest,
trigonal
Jerry.
and planar. Trigonal and planar, they are two different things.
Hmm?
Okay.
Horizontal,
Ask your
linear.
question. I am getting ready for
Yes, trigonal planar now.
Okay, so the test is suspended.
Sorry, man.
Because we can't end today. Thank you.
Man, 21. What's the answer?
I have a question though.
Which question?
21. 21.
Get the correct answer for this
One is C.
And when it's
I
just
have a question.
linear, it's
Ask your question.
Ma, that number 21.
I also have a question.
Number
Oh.
what?
21.
Can you go to number one?
Okay.
Number one.
Number 1, please.
No, number one.
Number
This is
1.
not number 1 now.
Number 1. Ma, how is he young?
Ma,
No,
I have a question on number 1 and 21.
Okay.
That number 1, why is it Aeon? Why is it not lattice?
Why can it be lattice
Yes.
now? In
I
ionic
thought
bonding.
lattice is the arrangement of ions now.
Lattice is the arrangement
Lattice,
of
when you're
ions,
talking
ma.
about lattice, you're talking about a metal. The arrangement of
Man, number
ions.
13, number
Lattice is not a
13. I know
metal.
that's number 13.
You are talking
Lattice for
about
ionic bond.
lattice. Listen, is in metallic bonding you're talking about lattice because you have so many ions you are aligning in a regular pattern.
Sorry, ma, I saw in my textbook that
You're
is
not
lattice.
Ma, but in
listen.
my Lamla
But listen now, everybody listen.
Listen. In ionic bonding, you are not arranging ions because you're dealing with one electropositive and one electronegative. You're not arranging anything. In lattice, is in metallic bonding, you are arranging so many things because there are more than one ions. You are arranging them in a regular pattern. When you're talking about arrangement of lattice, is arrangement of ions in a regular pattern. In ionic bond, you're talking about an atom transferring to another atom. So understand that, please be careful. The all textbook is not everything that there's not all textbook that you see and read. Go and read the recommended textbooks. So you don't, someone will not go and confuse you.
But what is
more than one
I
positive
think take it
ions.
to the number 8 and 9.
Which other question?
What
happened to that?
When electrons are in ground.
Number 13, number 13.
Trigona is different from
Man, what's the
planar.
answer for number 13?
What is tree? What is plane?
Number 14.
What is something that is on the plane?
Linear, man.
Linear now is straight.
When you talk about planar, so something that is linear. I know that question.
Number
18. 18.
For I thought hybridization occurs when electrons.
Man, number 13.
There must be an excited state for them to hybridize. I said it several times now.
Number 14.
Number 13, Number what?
Number
14. Number 21. 21.
Number 14.
13.
Yes, ma'am. Number 14.
What is it's sublimation.
Thank you, ma'am.
13.
11 and 12, ma'am.
Ma, I have a question.
11 and 12.
Yes, ma'am.
Please go back to your slides.
Man, number 13, please, man.
Number 21.
A metal is made up of atoms.
11 and 12.
Ma, please, number 20.
But what's the answer for number 10?
Hey, this is
What's number 11?
If you look at 11, go to your. I stress on those number 10 and 11. I stress on them in your
Excuse
manual.
me, ma'am.
Go to your slides.
Ma, that number 6. Number 6.
Man, number 13, please, man.
Number 6 is dipolar now.
Like if the answer is dipolar, then what is coordinate
Man,
ionic
number 13.
bond?
There's nothing like coordinate ionic. So that's why whenever you're in an exam, understand you have coordinate covalent. You don't have coordinate ionic. So whenever
What about number 8 and 9?
There's nothing like coordinate ionic.
Man, number
8 and 9. All covalent bonds are not polar. Some covalent bonds are polar. So not all covalent bonds are non-polar. Understand that. Some covalent bonds are polar.
Okay.
But all ionic bonds
number
are
21.
Polar.
Number 13, man. Man, number 13.
Wait, you didn't answer number 9.
Number 9.
Man, number 21.
Number
13.
Number 9, all ionic bonds are polar. They say some ionic bonds are polar, which is false because all
Number
ionic bonds are
2,
polar, not
gas,
some.
gas.
Thank
So
you.
Number
read
13.
the English, understand the English very well.
21,
Number
21.
13.
Number 13
Is gas.
is gas now. I said it now. Gas, you can compress all sides, up, down, sides.
Yes. It's polar.
Number
Sorry,
what
guys.
again? I think we are good to go. All the questions are answered.
Excuse me,
So,
I have a question.
21.
number what?
21. 21.
There's nothing wrong with 21. 21, tetrahedra is for ethane, trigona
I
is
can
for
help
18,
explain
then
21,
the
ma'am.
sign is planar. So I don't know your problem then. So the
Yes,
answer
excuse
is
me,
C.
ma'am. Yes, ma'am. Please, I have a question.
Ask your question before I go.
Ma, you said metals are made up of atoms. Is it not supposed to be iron?
No.
No, it is atoms.
It's atoms, not ions, please.
It's in the slide.
It's in the slide. I even highlighted on it. Go and read the slides.
Yes, ma.
Any other question?
Yes,
Ma,
ma.
21, 21.
Answer 21
I help
several times, not
explain
this one again.
21.
I've answered 21 several times.
Number 1.
Yes, ma.
Number what?
1.
Okay, I wish you guys the best.
Yes, ma. Yes, ma.
So now, like I said, the last other slide that was updated today, go through it, generate questions. That because my class ends today, I will not have any other time. Just the way I generated this question, generate questions for yourself and answer them.
All right,
okay,
so
one of the questions you're supposed to know is how to hydrogen bonding in compounds, how to determine it, and all that I was talking in the class today. Just
yes,
go and
yes, ma. I have a question regarding hydrogen bonding. As was that hydrogen bonds more with nitrogen, oxygen, and fluorine. But is it because of their electronegativity or because
start the question again? Hydrogen bonding that's
hydrogen bonds more with fluorine.
The lights.
Hydrogen bond more with what? Fluorine.
Nitrogen, oxygen, and fluorine.
No, not only them. We're talking about highly electronegative atoms. These ones are the popular ones used in the example. Is not limited to them.
Okay, ma.
Because they are common ones. No, it's not. So anyone that is highly electronegative, it can go.
Okay, ma. Thank you, ma.
All right. Thank you. So bye for now. I wish you success. Bye.
Ma, please, can you show that number 20?
Thank you, ma. We love you, ma.
Number 20 what?
22.
It's in your slide. Go and read it. People are not reading. Go and read your slides. It's in your slides.
I want to see the question.
The number of electron in orbital, in p orbital is what?
Ma, please, number 11.
Okay, thank you.
Ma, number 11.
Number 11 is in your manual. Number 4.
Number 11.
The following are types of bond. Except chemical bond is not a type of bond. Chemical bond is not a type of bond. Dipolar bond is a bond. I did that intentionally. Chemical bond is not a bond.
But what are the examples on that dipolar bond?
Dipolar bond can also be coordinate bond, can be dative bond, can be coordinate covalent bond. It's the same name. No, I highlighted it on the slides. So it's the same thing. If you're talking about dative bond, you're talking about dipolar bond. They are the same. They have different names.
Yeah, but it's not cool.
Oh, sorry, ma. I thought dative bond is covalent bond. Coordinate covalent bonding, ma.
We have dative bond, we have dipolar bond, we have coordinate bond, coordinate covalent bond. About 4 names.
That means coordinate bond is different from coordinate covalent bond.
But it's not normal covalent, it's coordinate covalent.
Okay, the dative is covalent and coordinate covalent, ma.
Yes.
Okay, ma. Thank you, ma.
Madam, is coordinate bond is different from coordinate covalent bond, ma.
They are the same thing. They are the same thing. They can be called coordinate bonding. They can be called coordinate covalent bonding. They can be called dative bonding. They can be called dipolar bonding. So whenever
Ma,
they're
but
talking about that, they're talking about the same thing. They're like synonyms. If there's nothing like that, at times you can be confused with things like that in the exam. Nothing like coordinate ionic. So if you don't know your onion, you say as long as there is coordinate is the answer. Just to confuse you. So you have to be sensitive when you're doing CBT. Don't rush. Read and understand. I wish you the best. Bye.
Ma, please, number 11.
This student, I'm tired. Number 11 is in your manual.